Welcome, everyone, and welcome to Track 1, Operational Resiliency and Critical Infrastructure. I'm going to jump right to the first session. Our first presentation is Consequence-Driven Cyber-Informed Engineering, and our moderator is Wayne Ostad. I'm going to give Wayne a brief introduction. Wayne has worked at INL for 29 years with more than 20 years of experience building impactful national security programs. As Chief Technology Officer for National and Homeland Security, he provides leadership and strategy for the collaborative R&D, infrastructure, and partnerships needed for critical programs. Wayne acts as Chief R&D Officer for a program called CYMANI, and that's a DOE institute led by the University of Texas, San Antonio, focused on economically viable and pervasive cybersecurity and automation and supply chain. Wayne also leads the Secure and Resilient Cyber Physical Systems Initiative for the laboratory. So with no further ado, I'll turn it over to Wayne.
Thank you, Sherry. Welcome everybody joining this discussion. I think you'll find it very engaging, both based on the subject matter and the panelists. It's a mouthful to consequence-driven cyber-informed engineering, but its motivations stem from the fact and lack of predictability of what adversaries are doing, and some sense of loss of control on the side of the cybersecurity side of things, from a standpoint of what you're measuring risk and how do you respond to them. And fundamentally, as an engineering laboratory, about a decade ago, we started looking at this challenge of cyber vectors to cyber physical systems and infrastructure systems differently. We had some seminal research in the area that has been translated into textbooks and formal training methods, as well as some licensees to indoctrinate this into some more standard engineering practices. And fundamentally what it does is orient you towards the consequences that you're trying to manage. And I think that's very analogous to achieving resiliency for both cyber and physical threats. So without further ado, let's advance the slides here and talk a little bit about the panelists that we have here. So first off, we have Sarah Freeman, who's also from the Idaho National Laboratory. And she is a national expert in threat actors, both criminal and nation state, that have been attacking our infrastructure and cyber physical systems over the last several decades. So she's very steeped in several areas. And she's also one of the co-authors of the book that we put out, Countering Cyber Sabotage, that lays out the CCE principles and is a major basis for the training classes that we're running as we indoctrinate and incorporate this into other licensees that are incorporating this into their practices. We also have Marco, who is one of our largest licensees. Burns and McDonald has a subsidiary, 1898 & Co., which has an interesting history of where they got to that name. But they are steeped in the engineering and integration expertise associated with these critical systems and infrastructure systems. And he has a lot of crossover experience with ISA standards committees in these areas, and is instructor and technical authority in that area, as well as very steeped in the FBI's InfraGard sections, specifically in some of the maritime and oil and gas industry there in the Gulf of Mexico area. So both of these folks are very threat informed, very steeped in the CCE methodology, and come at it from different perspectives. The research laboratory perspective, and somebody who is dealing real time, every day, every week with the threat actors and what they're doing across our infrastructure, and someone that has to actually deploy and integrate and configure and engineer systems so they can be more resilient and resistive to these. So I think it should be a healthy discussion. So first off, I think I'll turn it over to Sarah, who will give you a little bit of background about what CCE is and some of the motivations and why it's different than some other methodologies out there. So let's see if I can hit the next slide. There we go. Okay, Sarah.
Thanks, Wayne. So if you are unfamiliar with consequence-driven cyber-informed engineering, which almost nobody calls it that because it is a mouthful, if you're not familiar with CCE, we thought it was relevant to give just a high-level overview of it. Of course, as Wayne mentioned, there is a book. There's also a number of different materials, white papers that describe aspects of the process, which have been released on the internet through DOE. So you can find those as well. The motivation, I guess, behind the creation of this methodology, as Wayne alluded to, was a history of trying to address cyber threat actors at Idaho National Laboratory. And those kinds of experiences came from a few different areas, one of which was the recognition, as a number of my colleagues were working through incident response, either for, at the time, DHS, now CISA, dealing with some of the mitigations after an event has occurred, as well as closer to my area, a lot more forward-looking threat intelligence. How do we interpret and understand where the actors are going? And then on the research side, how do we improve both the engineering and the cyber design of these systems for resiliency? Throughout those years, there was a little bit of, I guess, unmet expectations. We watched a number of events happen, expecting on more than one occasion that those events would be watershed moments that would fundamentally change how we secured critical infrastructure. And in almost every single case, we were unfortunately wrong about what happened after that. Over time, we've been able to see how growth and capability on the adversary side has actually picked up in some areas. So it was really critical for us to try to very quickly inject some insights into how threat actors are targeting these systems so that we can better improve the defense of that equipment and fundamentally those processes. There is a starting philosophy, we'll call it, for CCE, which is that if we consider a nation state actor, a well-resourced nation state actor will eventually find a way to get into your systems. That in the beginning, when we first started talking about that, was not a very popular concept, but we've made some progress there. And then the goal of it is ultimately to change how people think about not just the security of their systems, but ultimately how we think about designing systems with security in the mind from the ground up. It is a 4-phase process, as you can kind of see here in the circle. The first phase looks at trying to understand what the worst case scenarios could be should a determined cyber adversary choose to go after your systems. Phase 2 and phase 3 are designed around understanding exactly how and what adversary would target in those processes. And phase 4, really the heart of what we're trying to achieve here, is recognizing or identifying modifications to the processes themselves that make certain cyber attack scenarios unviable. And what I mean by that is within critical infrastructure protection, we have one major advantage, which is OT systems, operational technology, tend to control physical processes. So if we think of something like the movement of goods and services in the oil and natural gas area, then you're going to have everything from the collection of product to the refining of that product to pushing it through pipelines, getting it through transport. I know I've summarized very, very quickly, but there's a number of things in that process that are controlled with digital components. If we intelligently identify potential worst case scenarios, there's sometimes modifications we can introduce that make things not possible. For example, and these are all very common in normal engineering practice, but things like recognizing that overpressurization of a system is bad, so we put in pressure relief valves. Depending on how that stuff is controlled, if it is not controlled via digital means, then it can't be hacked. So it's really about trying to change the perspective there for everybody who's looking at what and how can be manipulated within their processes. Could you go to the next slide, Wayne? One of the things that is really important, and a little bit of a discussion area, perhaps on this, just to be 100% clear, we at Idaho National Laboratory are not telling you to patch your systems, nor are we telling you that you should as they say, go back into the Stone Age and rip out all your digital components. That is not the intention of CCE. CCE is all about intelligently and deliberately looking at our potential risks and making risk-informed decisions about the cost and benefit of each one of those assets. In general, we like to talk about this as a continuum. CCE does have some aspects that are perhaps a little bit more onerous if you're more nascent in your cybersecurity posture. So because of that, we do like to have people have a good foundation before we start working with them or before they start going through the process of CCE themselves. The other aspect, and the reason why this is partially indicated on a triangle, is CCE is fundamentally concerned with the worst case outcomes, which by and large are conducted either by nation state actors or highly, highly sophisticated non-state actors. But in both cases, you're talking about things that could result in physical damage 9 times out of 10. In some cases, you'll notice as indicated here, those can result in national security incidents or events, things that are process or distribution disruptions that are felt on a national scale. At the same time, we're not necessarily talking about protecting your data. While important, and we would prefer that the information not be lost, we're really talking about things that are attacks that are focused on disrupting or destroying the safety elements of your processes. One last thing to highlight on the slide, you'll notice in the middle there, there's another acronym, cyber-informed engineering. Cyber-informed engineering is the broader philosophy of which CCE is one aspect. Within cyber-informed engineering, we are encouraging that those that are designing and building systems consider the cyber implications of everything they're doing. CCE is not the only way to inject that kind of idea into your work, but it is one process if you're interested in following on that. And with that, I was going to give it over to Marco so he can talk more about this.
Yeah, absolutely. And what I'd like to build on is everything that Sarah has really said here is, you know, from whether you're at a refinery, oil and gas facility, we try to, from with our basic automation, we try to keep our processes in check with a basic process control. And if our basic process control and operators cannot capture the process or try to change the process, then we really do rely on our safety instrumented systems or safety critical systems. Those are there. Those are 2 barriers that we put in place to be able to keep from having, especially in this discussion, an overarching hazard such as a active protection, overpressurization of a reactor, valve, rupture disc, collection basin, or environmental catastrophe with shelters in place and everything that emergency responders really focus on. So to protect against the very top arching critical barriers, such as mechanical reliefs that, as Sarah's indicated, are not hackable, we don't want to rely on those alone. And for the last 15 to 20 years, technology, vendors, and even asset owners, we've pushed folks to move into putting the systems to where there's more availability, more connectivity. So as you see on the right-hand side, these systems that used to be islands of information, whether they were full pneumatic controllers or somewhat analog to digital single loop controllers, have all been ripped and replaced and put in newer technologies, newer control systems. And along that journey, we've actually started migrating over to converged systems or integrated control and safety systems. So while that's given us better analytics, better maintenance, it's also provided a means to an end. As Sarah was saying, we've got cyber actors and nation states that are banking and hoping that we actually connect these systems, whether indirectly or directly, somehow, some way. So by taking away the bottom 2 barriers from a cyber actor or cyber scenario, this could actually fundamentally have great impacts to the community and to emergency responders within this. So we have to make sure, as Sarah was indicating with the CCE process, is that we go and we understand what are the mechanisms you currently have in place, what do you have, what are your safeguards, to be able to understand that, because we need to have these physical protections still in place. And as Sarah mentioned, we're not saying get rid of all digitalization efforts, This is just saying understand what you have and put in stopgap measures or identify the stopgap measures and be careful. You know, the last couple of years we've been dealing with COVID. And so we've put engineers and tech support and OEMs and support connected to these systems for availability to be able to support the systems. And that has actually created a vector in from trusted vendors, but we don't understand the untrusted or unverified trust that could be coming into your environment. And the CCE process really highlights that and really does a deep dive into understanding all of that. So identification, mitigation are key pieces to that. And as this bullet says in the very bottom is that, you know, even the most sophisticated safety instrumented or safety critical system, it can be defeated by an attacker if there is a means or avenue, whether that's an internal actor, external actor, nation state. We've got to be able to protect these systems further and much more detailed. So the big thing that I see, especially in the industry, is going out to in the field, whether it's refineries or pipelines, is understanding how your systems are truly interfaced and truly designed and implemented in capturing all the red lines as the as founds compared to what you may have on documents as built. And it's very important that you understand what that delta is. And doing a process like CCE allows that. So some key pieces there is understanding, you know, the myth of our safety systems will protect us is a true statement. However, we have now moved these digitized systems up into where we have remote access and vectors in. So we have to be very careful with that. Now, moving on to the next slide, just some key conclusions for using CCE that we've seen, especially in oil, gas, chemical, and maritime and electrical sector, is that you do have to define what your most critical functions are. Not every adversary is going to want to cause an explosion or an environmental catastrophe. The method of the madness may be to just impact, degrade, or derail systems to impact reliability, resiliency, performance, or inhibit the functions. And so there could be a lot of pieces to that. Identify those methods from an engineering standpoint of how those could be done or the compromise of those systems, and then evaluate your complex systems or the systems of systems. And then the key piece at the very bottom bullet here is apply proven engineering, protection, and mitigation strategies, and really look at it from not just the vendor's perspective or the asset owner perspective or the operations perspective, but look at this also from an engineering attack vector, advanced adversary with the knowledge, with the engineering background, and with even training on the systems that you may have in your industry, in your field, and in your design. So really to protect those critical assets. So that's the main piece there that I wanted to talk with the slides that I had, is that the CCE methodology really provides a really good avenue. And thank you, Sarah and Wayne and Sherry, for allowing me to come in and speak. So I'm going to wait for others to talk now.
Okay, thank you, Sarah and Marco. We have a chat. If folks have questions, go ahead and type your question in the chat. I have some questions that come to my mind and some thoughts just to spur things along. You know, one of the things that I find attractive about CCE is it's about shifting your mitigations and your risk basis to things that you control. If you think about it from a physical standpoint, we know we don't control the weather, we don't control hurricanes. We have some idea about, you know, what that threat basis is for weather and other things. So we design our systems to deliver our functions independent of whether we can predict whether the weather is going to hit us in a particular fashion. And same thing, it's very hard to predict what threat actors are going to do, very hard to understand the totality of the vulnerabilities and technology you're applying, but the engineering process and the function that you're delivering is yours. And so that's where you start seizing some control over this risk. So framing it that way at a high level, you know, what are some of the specific lessons, some of the biggest lessons that maybe you, Sarah, have seen based on evaluations that you've seen on very critical sites? And Marco, from your perspective as a recent licensee, dealing with these infrastructure systems at a depth that a national laboratory doesn't have, I'd like to hear what some of your lessons are right off the bat. Maybe we'll start with Sarah and then go to Marco.
So the first thing is, and it's something you touched on in the little bit of that introduction to that question, CCE recognizes, and I can say this wholeheartedly because this is my job, that there is only imperfect information with regards to threat activity. In the best case scenario, and in some cases, maybe the worst case, the best case scenario is you get a phone call or an email 24 hours out that says you're going to come under fire. And that's frankly highly unlikely. It's what we aspire to achieve, to have foreknowledge of what these threat actors are doing, but it's unlikely with that. Given how things operate today in terms of cyber operations, we can hope for that. What we can say is, as you alluded to, there's certain trends in activity, but rather than spend all the energy fearing how those trends and those actor techniques are going to be used against us, we stop focusing on that part of the conversation. We start talking about our own systems. To your question, one of the biggest lessons that I think we knew going into it, but we hadn't internalized even at Idaho National Lab, was how critical it was that an outside observer not make these assessments, and that the engineers themselves, particularly the ones who have been working those systems, seen them fail on occasion, troubleshooted different aspects, built them from the ground up, that they be part of those conversations. 9 times out of 10, the person with the scariest idea in the room was not the threat analyst. It was the person who had worked with that system day in and day out for 20 plus years. And over time, on their lunch breaks, had started thinking about, you know, what would be really bad if this happened. The other thing that we observed, there's a lot of organizations that think they have IT and OT security partnered. And in reality, they're often a little bit more disconnected than that. So just being able to know who your peers are and start having conversations about what the transitions might look like, especially in phase 3, when you start saying, how can an actor or attacker actually achieve this? That part was really critical. And then kind of I guess a little bit of a corollary there, recognizing that the partnerships can't stop there. So any information that you learn from the process, that you get value if you're willing as an organization to share that outside of your organization. And by that, I mean, if we're looking at the energy sector, the value from participating in one of these assessments with an electric utility is if you can then share your insights with your other peers and the other electric utilities. Or if you can share the things that you're most concerned about with government or other private intelligence security entities, then there's a little bit more clarity about the significance of some threat actor activity. I guess there's one other thing I should have said in the middle there when we were talking about IT and OT security and partnerships. I've also observed that there's usually 1 or 2 organizations that have never been brought into the conversation. This was actually more apparent on the DoD side. Things like procurement entities that have a wealth of information, but for whatever reason, they don't get asked or brought in or provide data when we talk about implementing security solutions. So it's a really big circle, especially when we start saying, how can we mitigate these threat actors?
Yeah, very rich answer, Sarah. Marco, some perspectives?
Yeah, just some perspectives that using the CCE approach and even a standards-based approach is identifying, you know, from the different sectors in the industry, literally, you know, boots on the ground, identifying with clients and asset owners that they've muddied the lines or the lines are unclear or blurred between the IT and OT infrastructure when it comes down to discussions about determining where a clear demarcation and isolation point is. It sounds good in boardrooms and discussions, but when you get out into the field, being able to identify where we can disconnect and operate with resilience is difficult. It's the discussion that, again, the last 5 to 7 years, we've moved to more cloud data, more cloud analytics, remote access, interdependencies regarding billing and tolling systems, or like top multi-load systems. So even the operator of today is highly reliant on human machine interfaces. And so a lot of the technology has been moved away from the field into the control room. And so when those systems are unavailable or you can't disconnect, some of the biggest things is that training and operators of today may not have a clear understanding of where to actually, how they can still operate and where they can disconnect from. So I think it comes down to training, awareness, culture that help drive these things, but also making sure that your incident response plans, which are a key element to all this process, is making sure that you have a sustainable, resilient response that you can implement. So CCE allows many folks to be able to determine the how, the what, the why, and the how comes, and also the ability to respond and recover. Those are key elements in today's world.
Yeah, thanks for those insights. I'm gonna go down to kind of a next question that's kind of associated with what type of skills and teams that you might need. I'm going to tell a little bit of a story first to frame it, and then I'm going to start rolling some of the questions I'm seeing in the chat together on some questions. But I'm about to ask, what sort of teams and competencies do you think make for the best teams in order to do a CCE evaluation? And I can share a story about a training event that I saw in a cyber strike, in which they had some of the IT folks and some of the operators together with some of the managers, and they were going through a Ukraine-style power grid attack, in which while it was going on and the mouses are moving and people are freaking, the operator just said, well, I'm going to unplug the network connection to my screen. And the IT guy go, oh, no, don't do that. Your machine is actually virtualized. That really doesn't stop the network traffic to the attacker. All you're going to lose is your visibility into the process. And then the manager in the room asks, oh, wow, do you actually have the ability in the call center, either by you have somebody waiting to pull the plug, or where the plug directly connects? Is that even possible scenario? And so my observation from a training standpoint was that it was very valuable to have these different layers of executive responsibility and OT leadership and IT talking through some of the challenges on a tabletop exercise. That's during an event. What do you think is a good team combination as you're going through this consequence analysis and this systems and targeting teardown, and ultimately trying to get to the mitigation phase? What are the most valuable skills and team members for that? And maybe I'll reverse it and start with Marco and have Sarah run cleanup on this.
Absolutely. Thank you, Wayne. And yes, so obviously IT security, but operations, the operations side of it, the control engineers, automation and control engineers, even as far down, operators for sure, senior leader operators that understand everything from the sounds of the unit to how things are typically supposed to operate and what looks inaccurate to them. Very important to have at the table, including your HSE folks, your safety individuals that may understand what are the impacts to this system. But I would also say that some of the folks that often get left out, or that have very much need to be in the discussion, is the electronic techs or the instrumentation and electrical folks. Many of these systems are now smart. So understanding if the actual instrumentation is valid or providing accurate measurement. So I think the measurement crew, especially with pipelines, have got to have them at the table as well to make sure to understand, are these readings even accurate? Is it even possible? Are these manipulated, manufactured readings? I think they need to be at the table for these discussions. And I will go one other step further, is that there is a mission that's out there. It's called ICS, so Incident Response for Industrial Control Systems. And I think that falls under ISA's Global Cyber Alliance, and that ICS for ICS actually follows an incident command system that is formulated from FEMA. So the same ICS that you would take for FEMA type responses has now been integrated into doing that for industrial control systems. So if you're not familiar with that, you could also look at that as a complement into incident response preparedness. And it's a really good strategy to look at.
Sarah, anything to add?
No, I think Marco did a great job there. I can't think of anyone else I would include in the mix, at least in the initial phases.
Okay, so I'm going to roll to the chat a little bit, and I'm going to kind of lump a couple of questions together. There's a question most recent about from supply chain perspective, and how a natural gas pipeline supplying fuel to an electric power plant can cause cascading impacts. I mean, we've seen some scenarios with Colonial Pipeline, and there's also a question about the pandemic side impacts and the increasing amount of remoting. And I think you touched a little bit on that, Marco. And so I've kind of combined some interesting perspectives between supply chain, although that means a lot of different things to a lot of different folks, right? And pipeline type interdependencies and how we're going remote. Any comments on that? Maybe Sarah, I'll start with you, since I think that's near and dear to your heart.
It is. Actually, I was just having this debate yesterday. There's a difference between supply chain logistics and dependencies and supply chain integrity. For the purposes of the pandemic, obviously, I think the focus is more on logistics. I do think that the pandemic has highlighted some weaknesses in the dependencies that perhaps were not previously observed, at least not the disruptions of that. But when you talk about preparation, it's not just necessarily you have to have firsthand experience this in order to recognize you have a weakness there. There's a lot of value, obviously, in something like CCE, which encourages you to think creatively about not just the physical components that you might rely on, but also the data that's being shared throughout your enterprise or from third parties. But also just tabletop exercises in general, training exercises where you go through scenarios and you discuss what the outcome would be for each one of those issues. In terms of this is a quintessential example if you start talking about the electric grid in some ways, because it is one of the prime and most complex systems we have to deal with. And so the dependencies can be a little bit challenging. But at a high level, not talking about any specifics, if you disrupt natural gas supply in a region that has a large amount of generation, and now I'm going to get kind of nebulous here, that supply is disrupted for a long time, then it is possible that you will have a decrease in generation, which in turn will mean that they will have to move additional generation capacity from other sections of interconnections in the grid. In general, grids are, especially in this country, thank goodness, we spend a lot of time and energy trying to make our system resilient through interconnections. Obviously, however, if you are somebody who likes to follow the news and that kind of things, there are periodic disruptions that you don't necessarily prepare for. Case in point, ERCOT last year. So any single time we talk about the resiliency of a system as a whole, that is a useful exercise, but we also have to consider the modeling at a regional level. Ironically enough, this just happened a couple of days ago in mostly Kazakhstan, but you should look into it. There was a power disruption. As far as I know, I haven't been able to figure out what the root cause was. I'm not sure they've said yet, but there was an issue that required them to disconnect from their regional suppliers, their neighborly suppliers, and they were unable to meet demand with their local generation at that point. So all of these things happen a lot of the time, which is good news for us, because it does mean that in a sector like that gets tried regularly, whether it be by normal technology failures, acts of God, weather, they do tend to be more resilient. But it's also interesting the times we fail to consider what our dependencies are. And one final anecdote. So actually I want to say it was in March 2018, but it may have been 2019, there was a third-party supplier that provided billing services to a number of natural gas transport companies in Texas. And when their system went down, those three companies chose not to move product because they couldn't figure out how they would do the billing effectively. This was before Colonial. And so it's important to keep in mind that there are many, many things that would not under normal definitions be defined as critical, but for those business operations are deemed critical. And that's a good lesson to keep in mind as you are considering your own architectures and systems.
Yeah, those are some great points, Sarah. And remembering that Marco is in the whole other country of Texas, I believe, and has a lot of oil and gas perspectives. You know, one thing that struck me about the events with ERCOT on the weather side is that some of the wounds were inflicted from a physical standpoint, right? Sensors and other things that couldn't stand the weather. But some of them were self-inflicted by our own algorithms and schemes. There was actually power shutdowns because of pricing systems to the gas pipelines, which worsened the gas pipeline distribution as they were trying to shed load in response to mismatch in generation. And so these interdependencies can get complex. And one of the things that CCE tries to do is to get at, for those most important functions, don't blind yourself with those layers of complexity. Get to the fundamentals of what has to be delivered. The complexities are appropriate for other types of analysis, but maybe not for certain critical deliveries. But you probably have some perspectives from the oil and gas supply chain that having living and breathed it with the FBI, InfraGard, and the Gulf region. And so I'd like to hear some of your thoughts.
Yeah, I think Sarah had some really good points regarding disruption and the interdependencies, and I think it's important. Some of the things that I can speak to is making sure that you address the systems holistically, and it is important. In the oil and gas side of it, we've got many moving parts, including MTSA facilities that are Coast Guard regulatory, and so we've got CFATs, we've got Coast Guard, we've got different things and different avenues. So we got marine terminals, and we've got gas, we've got oil movements, we've got offshore, we got Gulf of Mexico, we've got so many different pieces to it. And any of these events that adversaries will look at and look to see what those weaknesses were and how they could actually use them to their advantage in some form of gameplay to be able to determine what those can be. So, for example, identifying if there's weak spots where, if there's a cold front coming, what other industries can you target at that same time? With the oil and gas side of it, we're not just producing fuels. I mean, we're making specialty chemicals even for sterilization processes. So there's so many things that are critical to our nation that need to be secure. And I think it's important to note that there's a lot of really good frontline workers and security aspects. The silver lining is that many companies are staffing up and they're getting folks to the table. The security directives with TSA is also pushed for having a cybersecurity coordinator or two coordinators to be 24/7, 365. There's a lot of prescriptive things that are being pushed back, but at the end of the day, I think we really need to pull apart our systems and understand we need to think like an attacker, but design and deploy as an engineer. That's what we really need to do. Is we need to put in boundaries and constraints around someone impacting or some country impacting our critical infrastructure, whether it's oil, gas, chemical, or maritime even.
So I'm going to shift a little bit. I think we have a hard stop at 1:18 to allow people to shift to different panels at 1:20. But I'm going to combine a question that's in here and a question that's on my mind. The question that was in the chat was along the lines of how rural and smaller or disadvantaged communities can get assistance with their infrastructure evaluation. And I'm going to put a slightly different slant, given who I assume is attending a lot of these panel sessions. We think about resiliency and CCE as applied to utilities or providers often, right? And for a lot of folks dealing with critical functions and both cyber and physical challenges, it's really more of a state and local region that's having to deal with this aggregation of utilities and systems. And so this kind of gets at the core of interdependencies between sectors or utilities. how might either the small disadvantaged regions that may have some critical functions or the state and locals that have to deal with this aggregation of utilities and interdependencies, how should they be trying to adopt CCE or encouraging their member utilities to use CCE? What do you think is the right approach for those frontline regional managers that have to consume these critical services?
Sarah?
I didn't start with somebody, and I should be on Sarah. So we'll start with Sarah on that one.
That's a hard one, Wayne. I think it's hard because, well, not just because it's a hard problem, but it's also hard to speak about the generalities. In terms of, in general, not necessarily CCE related, there are a lot of resources that can be leveraged provided you have the right contact information and depending what sector you're in. So CISA and FBI both come to mind because they tend to have contacts and local assets that they can devote to these problems. CISA in particular has spent a lot of time, and that's the Critical Infrastructure Security Agency, I believe. I hope I got that right. Somebody's going to yell at me on this. But DHS CISA, they have a number of resources available online that you can use to do kind of self-evaluations. If you do come across something that looks nefarious, there are people you can reach out to and they will help you. In terms of implementing CCE, I think if you have either access to the book or some of the underlying processes, or if you're able to attend one of the training sessions that INO offers, I think there's aspects of CCE that can be implemented at a smaller scale, even if you don't believe that you have the resources necessary to perform a full experience. So I think, what I would say is there's a lot of information out there if you're willing to take some time. And there's plenty of people that are both at the lab in CISA and FBI that are willing to talk to you as well. Context is key. So knowing what industry or what your specific situation is would be helpful for me.
Okay, Marco, unless Sherry tells me otherwise, I think we have 2 minutes. And so you're our wrap up, I think, on this.
I really didn't have much to add there, but there were a couple other questions in the questions tab that I don't know if we covered.
Yeah, I want you to. I know there's a lot of Burns and McDonald ones in there, so just free reign.
So there were some good ones. What does the CCE engagement look like as far as cost or complexities? At least from the approach that we've seen, to really do a deep dive into CCE within the 4 phases that. That's usually up to a 12-month engagement, but that's looking at many high consequence events for your facilities. The second question that came in is what industries are currently using CCE methodology. And while I can't name the asset owners, I can tell you power, bulk power, utilities, transmission, distribution, also some oil and gas and key pipelines.
Water as well, water sector. Yoast Systems is doing water.
And maybe I missed some, Wayne, but those are some of the key ones, and we're starting to see more requests for engagement from ports and terminals, critical key ports and terminals, not just in the U.S. but abroad. Discussions around that, and then I think the other question here was how does CCE framework interact with safety significant system framework? For example, in the nuclear industry, and I don't know the answer to that, but perhaps Sarah or Wayne, you may know that one. And if not, we can always table it and answer it later. That came from Ben Colgrove. But that's really all the pieces that I had. If Sarah, if you had anything to add to the discussion before we close out, or Wayne.
So I'll just jump in there. I was typing responses to a couple of these questions.
Great, thank you.
So CCE doesn't directly integrate with those frameworks, particularly in the nuclear industry. That being said, it was primarily inspired by the nuclear industry, and because of a lot of the work that INL has done there. CIE in particular does have more nuclear specific documentation, but we are in the process of trying to implement or describe CCE in a few different I guess, standards. So it's been lumped in a lot of cases with discussions around vulnerability assessments. And I will stop there in case Wayne has something to add.
No, I think you answered it perfectly, and I'm wondering where maybe there's some questions going directly to you guys that I'm not seeing. So thanks for picking those up. Sherry, we're 1 minute over, so I'm going to pause and take my instructions from you.
No, you're fine. It was actually 1:19 that you needed to bring it in. So we have a hard stop at 1:20. So just wanted to have enough time to sincerely thank all of you for taking the time to talk about this today. I think it's been extremely enlightening. We've had good participation, great questions. I hope you'll find a way to continue to interact with some of the folks that want to know more. And like Sarah said, there's a book and it's a good read. And this has just been a great panel, and I want to thank all of you. And just for everyone's edification, at 2:20 today, during the break, we're going to be showing a video on CCE. So potentially you can learn even more about it. So thanks, everyone.
Thank you. Thank you, Sherry, Wayne, Sarah.